Hi, in this video we'll talk about alternating series. So an alternating series is a series that alternates in sign. So that's the term we're using, alternating, is to say that I have an example here where the first term is positive, then you can have a minus, then you have a plus, then you have a minus, and so on. So that's the alternating part of this. So to write this, of course, we have seen this in the past. It's going to be a power of -1. And then the other term, oops, erase that. The other term has a 2n minus 1. In this example, it's 2n minus 1, there's odd numbers, so I'm starting from n equals 1, right? So when n equals 1, the first term, the negative 1 to the power would be the power of 2, so it's positive. But then for this one to match that, this is 2n minus 1, right? Now there's not only one way to write it, like I wrote down here. It could be from 0, if then your first power has to be the power of 0 to be positive, and then you would be 2n plus 1. So there's not a unique way to write an alternate series. The one we're going to most usually going to use is when we use the power starting from n equals 1. But it's not necessarily. You can also have an alternate series where the first term is negative and moves on like that. Now, an alternate series is a form. It's a series of this form. Now we're going to separate, like we did above, the alternating part, which is the -1 power, with the bn part. But if we do that, we can assume that the sequence bn is positive, right? So the negative sign comes from the power, and we can assume that the bn's are positive. So if we identify an alternate series like this, we're going to have a very simple way to test for convergence, and this is the alternating series test. So it's going to be a very simple way to check. So the alternating series test says that all you need to do is to check that the sequence of the terms that we know that we're treating these as positive already, that sequence is decreasing, that the limit of the bn's is 0, and that's it. If you know that the sequence is decreasing, the bn's, and they go to 0 as a limit, then you can guarantee that the alternating series converges. This is a very, like I said, it turns out to be a very simple thing to prove. So let's prove it. So I have stated again the alternating series test, just to refer to it for the proof. So we know that to prove that a series converges, the definition means that, I'm going to write like this. So this guy, from 1 to infinity, -1 to the n plus 1 bn will converge if the sequence of partial sums converges, right? If the sequence, so this is the definition of a series to be convergent, and we have used this in the past. So I'm going to write, if you don't remember who was the sequence of partial sums, well, the sequence of partial sums, we called it like this. It was the sum stopping at n of these terms. So the first n terms, you add them up. Okay. So in this scenario, we're going to assume, of course, we're going to use the alternating series test. So we want to assume these two things. We want to assume that the bn's are decreasing. Of course, we're assuming that the bn's are positive, okay, like we did before, and that the limit is 0. Okay, we're going to assume those two things, and with those two things only, we're going to prove that the alternating series converges. So to do that, we're going to take a look at the partial sums, and we're only going to look at the evens. Look at this. The S2 is going to be adding the first two terms, so it's B1 minus B2. Now remember that since the sequence Bn is decreasing, we know that B2 is less than B1, which means that B1 minus B2 is positive, correct? So let me write that down. It doesn't fit here. Let me move it over here. So this is positive. Okay, so I have it more than 0. Here I have it backwards, so this is positive, so I'm going to put it like that. Okay, now S4, I'm going to jump to S4. Well, we know that that means this is adding the first two terms, which is S2, plus B3, which is, in the way I had it down, B3 would be the positive term, and B4 would have been the negative term, right? But again, remember that B3 is, sorry, I had it backwards. Remember that B4 is less than B3 because it's a decreasing sequence. So this means that 0 is less than B3 minus B4. Right. So here I'm doing something that we know is positive and something that we know is positive. We're adding them up. So this is also positive. Not only positive, it's increasing. It's bigger than S2, right? Because we're adding this term, which is more than 0. So the idea is to keep going like this, and I don't have to do a lot more to convince you guys that if I did it again, of course, the S6 would be the S4 plus B5 minus B6, but B6 is less than B5, and that tells us that 0 is less than B5 minus B6. So again, this is bigger than S4, so the sequence, I'm only doing the evens, but it's okay. S2n is increasing. So it's an increasing sequence. Now, how are we going to prove that the sequence is convergent? We know, if you remember from a few chapters ago, that if the sequence is increasing and bounded, then it's convergent. Now, how can we find that it's bounded? Well, I need to check that the sequence is bounded, okay? So this is pretty simple. Look, B1 minus B2 plus B3. I can write this. This is the sequence, right? So this is a series. Sorry, I'm going to add that. I'm going to add minus B4 plus B5. Sorry, I had it backwards. No, it's fine. And so on. I could write it like B1 minus, open the parentheses, B2 minus B3, right? So this thing that I did here, so this negative with that negative becomes that positive, correct? And I can do the same thing here, minus B4 minus B5, and so on, minus, and I can keep going, right? Now look at this, B2 minus B3, I'm going to write it over here, B3 is less than B2, so we have that B2 minus B3 is positive, again, right? B3 is smaller than B2. So this says that the entire series is smaller than B1, right? Because you start with B1, which we're assuming is positive, and subtracting these numbers. In all of these, the numbers are positives, and you're subtracting them from B1. So B1 is my upper bound. Okay, so B1 is an upper bound. So there you go. The sequence is increasing. I'm not going to change the page a little bit right here, sorry. S2n is bounded above by B1. So There you go. So that's all we need to say that the series converges. Okay, so we prove this from scratch, and we're done. Now something that we saw here that is, so these ideas that we're using right here to prove that it's bounded is going to be very useful for something else. But let me just tell you an example before we move on. Let's move on to an example of something that we might use that over.